In this session, we want to look at more compound and continued inequalities. An inequality of the form 3 is less than x is less than or equal to 7 means x is greater than 3, and at the same time, x has to be less than or equal to 7. And so remember what that and means. And means intersection. It means what the two sets have in common. And if we look at the number line, here's the number 3. The numbers greater than 3 are off to the right of 3. The number 7 is over here, and the numbers less than or equal to 7 would be off to the left. And these two sets overlap in the intersection. Those numbers in between 3 and 7, not including 3. So we put a parenthesis around the number 3, comma, and put a 7 and a bracket around the number 7. So that would be our interval between 3 and 7, not including 3 and including 7. Let's look at an example. 5 is less than or equal to 2x minus 1 is less than 11. Well, that means that whatever x is, after you multiply it by 2 and subtract 1, that 2x minus 1 has to be greater than or equal to 5, and 2x minus 1 has to be less than 11. And now we want to solve this compound inequality, this intersection of the two sets. We figure out each set. We have 2x minus 1 is greater than or equal to 5. Add 1 to both sides. I get 2x is greater than or equal to 6. Divide both sides by 2. X is greater than or equal to 3. And 2x minus 1 is less than 11. Add 1 to both sides. We get 2x is less than 12. And divide both sides by 2. We get x is less than 6. So we have two sets now. We have x is greater than or equal to 3, and we have x is less than 6. So if we look at the number line, here's the number 3, and the numbers greater than or equal to 3 would be off to the right-hand side. The number 6 is over here. The numbers less than 6 is off to the left. Those two sets overlap each other everywhere in between 3 and 6, not including 6, and including the number 3. So we write x is an element, bracket 3, comma 6, parenthesis. And that tells us all the numbers in between 3 and 6, not including 6, but including the number 3. It turns out we can solve the same problem slightly different. We can solve one of those continued inequality problems by isolating x in the middle. Let's take a look at that same problem. 5 is less than or equal to 2x minus 1 is less than 11. We want to isolate x in the middle. Remembering, whatever we do to one side, we have to do to all sides. If we add 1 to the middle, we better add 1 to the right-hand side and add 1 to the left-hand side as well. We end up with 6 is less than or equal to 2x is less than 12. Divide by 2. And we end up with 3 on the left-hand side, x in the middle, and 12 divided by 2 gives us 6 on the right-hand side. And there's our interval between 3 and 6, not including 6, but including the number 3. Let's look at one more example. 14 is less than 5 minus 3x is less than or equal to 20. The first step would be to subtract 5 from the middle. I better subtract 5 from the left-hand side and subtract 5 from the right-hand side as well. Doing that gives us 9 on the left, less than negative 3x in the middle, less than or equal to 15 on the right-hand side. And now from here, divide by negative 3. And what happens when we solve inequalities and we have to divide by a negative number or multiply by a negative number? That tells us we need to switch direction of inequalities. So when we divide the left-hand side by negative 3, we have 9 divided by negative 3 is negative 3. The symbol switches to a greater than, and negative 3x divided by negative 3 gives us x in the middle. And when we divide the right-hand side by negative 3, that symbol also switches to greater than or equal. And 15 divided by negative 3 is negative 5. So that's our answer. Negative 3 is greater than x is greater than or equal to negative 5. And if we look at the number line, here's negative 5 on the number line, and over here is negative 3 on the number line. And we want all numbers in between negative 5 and negative 3, including negative 5, but not including the number 3. And that would be the region. Negative 3 is greater than x, and x is greater than negative 5. And as an interval, we start at negative 5, and we're going up to negative 3, and put a parenthesis around negative 3, and a bracket around negative 5, and that would be the solution in interval notation.